Alrighty, in problems number 16 and 17, they ask us to graph. Remember, we do that using our graphing calculator, at least for the time being. So we are going to go to our y equals and then enter in exactly what we see. So f of x equals, or y equals, negative x to the third plus 2x plus 1. So remember, whenever we need to get an exponent, we can just use that little caret button. That's 2 up and 1 to the right of 9. So negative x cubed plus 2x plus 1. So as we're trying to figure out a good viewing window, we'll hit second table to see where our values take us. So we expect this graph to have end behavior similar to functions that have a negative leading coefficient odd end behavior. So one will be going up and up to the left, and you'll be going down and down and down to the right. So it makes sense as our values get bigger and bigger that our y coordinates are getting way more negative. So smaller, yes, but more negative. And then as we go farther and farther left, our values are getting really positive. So a good viewing window, looks like all of our values are kind of extreme and kind of far out there until you get up to like -3, honestly, and even past +3, we don't really need to go. So I would say take our x's from -3 to 3, and then take our y's. Let's see, in that range, we go up to 22. Probably don't need to see all of that. And then down to -20. I mean, I guess we could. So we'll go -2 to, or -3 to 3 on the x for sure. And then maybe let's just even go -4 to +4, or -5 to 5. And we can kind of change things around a little bit if we want. I think this gives us a pretty good window. We don't need to go exactly from corner to corner, because then we wouldn't see this nice those nice turning points, those nice hill and valley, respectively. So from here, we include a quick sketch on our worksheet, I guess, and we want to make sure that we include our viewing window. So make sure that you say, oh, I'm going from -3 to 3, and what did we decide? -4 to +4. And then when in doubt, you can always plot more points. Give me a little bit of information about what you see. So your trace feature is going to be really helpful. Usually automatically will go to x equals 0 unless you have something else plugged in somewhere else. So when you have that, at least plot your y-intercept. Hey, it makes sense that it's 1, right? Plugging in 0, that cancels out, we're just left with 1. And then go ahead and label those hills, valleys. Maybe you can label that x-intercept. You're going to be doing all of that under your second trace feature. If you want your x-intercepts, those are your zeros, your minimums, your maximums, and then we only have one line graph, so we don't use intersect right now. We will, or we have, I guess, in the past, but we don't need to right now. Let's go ahead and find that 0, so option 2. Let's do the one over to the right, which is why we need to be specific about our left bound, right bound, because it doesn't know if we're talking about those two over here that are really close together or this guy over here. So when it asks left bound, you're going to select something to the left of it, hit enter. Changes to right bound, so you need to arrow somewhere to the right. Perfect, good enough. And then take a good guess, enter. Awesome. So it looks like you have the ordered pair 1.62, 0. And then go ahead and label that. Label any other number of points. I know there's not a whole lot of room on your worksheet, but tomorrow on the quiz, hopefully you'll get a little bit more room, or just more opportunity for more points that you can graph. Alrighty, so then we will move on to problem number 17. So now we have a different function. So we'll go under our y equals and clear out what we have. Looks like now we want y equals x to the 4th minus 4x squared plus 3. And again, we'll go to the second table feature to get some values. These are probably going to be relatively similar, except now this time around our end behavior is that of a positive leading coefficient and an even degree. So that means that we expect our graph to go up both as we go to the left and to the right. So makes sense. Yep, negative, 48, that's already pretty big. And then, +3, +48. This graph's gonna be very interesting because it looks like it is symmetrical. So we will probably be able to keep our windows pretty much about the same. Let's go ahead and keep them what they are, which they were -3 to +3 on the x-axis and -4 to +4 on the y-axis. And notice it is in fact symmetrical, so if we folded it along that y-axis, we would get the exact same thing on the left half as we have on the right. So just kind of an interesting feature for you. We'll talk about why that's the case later on, or if we don't, then you certainly will next year in pre-calc. So we notice that we have a couple distinct features about our graph. We can hit trace. We find that our y-intercept is 3. And some of these other points, I'm going to take a guess actually. If we type in 1, oh, look at that. Our x-intercept, one of our, looks like 1, 2, 3, 4 x-intercepts is positive 1. And I'd be willing to bet that that other one is negative 1. Also, just something to keep in mind, our degree is 4, and we see how many zeros? 1, 2, 3, 4? Almost interesting enough to be called the fundamental theorem of algebra. We'll come back to that later on in the chapter. But go ahead and include a sketch of this on your graph as well, indicating that your x-axis goes from -3 to 3, your y-axis goes from -4 to 4. Label as many other points as you can. Again, not a whole lot of room on your review worksheet. That's okay. Label what you're able to fit.